This week we are discussing the topics of polymorphism and dynamic binding. Actually, we already have covered polymorphism, so we'll be spending some time on it, but we'll be focusing more on dynamic binding. We'll explain all these concepts through some code here. And there is also a document, a PDF under the lecture for the week. So there are no PowerPoint slides. So read that document and look and watch this video completely. First, let's see some basic concepts. Here, let's look at some classes. We have a class called student here. A student has a name, status, a GPA, how many credits the student has completed, etc. There is a constructor here. Given the name, it will store the name and set the status to in good standing. So the student could be in good standing or on probation. And there are some getters and there are a few other methods. We will get to those later. But the most important thing is to know that there is a student class. There are two subclasses of it. Public class undergraduate student extends student. So there is a constructor for undergraduate student here. Then the other class is graduate student, extend student, and there is a constructor here. We'll get to some of the details in a few minutes, but the most important thing, as I said before, is to know that there is a student class and that is subclassed by graduate student and undergraduate student. So remember those things. Now let's look at some code here. Let's focus on this particular line. Student 1 equals new undergraduate student John. John is the name of the student, obviously. That is passed to the parameter constructor. So we create an undergraduate student on the right-hand side, and it is stored as a student object on the left-hand side. So student 1 is a reference to an undergraduate student. Student 1 is of type student. So there are some important definitions here. We declared student 1 like this. Student 1 is of type student. This is the declaration. If you want, if it is more comfortable for you, I can separate this into 2 lines. Okay. So student 1. So this is our declaration of student 1. And since this is the declaration of student 1, we say that the declared type of student 1 is student. See, we used student for declaring student 1. So we say that the declared type of student 1 is student. You will hear this terminology quite a bit in when you hear about polymorphism and dynamic binding. So it is important to know what declared type is. The second thing is that in student 1, we store a reference to an undergraduate student in the statement. So we say that the actual type of student 1 is undergraduate student. So there are 2 concepts. The declared type, what did we declare student 1 to be? That is one thing. The second thing is, what is the actual type of student 1? Here it is undergraduate student. We could have changed it to like this. We could do it like this too. In which case, the actual type of student 1 at the end of this statement would be a graduate student. The declared type never changes. As long as student 1 is valid, is accessible, its declared type is going to be student. But the actual type can change as you execute. So make sure that you have understood this idea very clearly, the distinction between declared type and actual type. We can use this idea in creating a bag of students. For example, here we have an array of students. Data is an array of students. So we can store both undergraduate student and graduate students here. The declared type of data is an array of students. The second thing that you should be, let me get rid of these lines here. We don't need them anymore. The second important thing that we need to understand is the difference between compile time and execution time. I know most of you know this, but still, when you are typing up stuff into Eclipse like this, okay, you type up some stuff here, right? At this time, all that Java is doing is ensuring that the code is syntactically correct. It is, there are no errors, that there are no situations that violate the language rules. It is not executing anything. For example, look at this line here. We create a scanner object so that you can read from the keyboard. And scanner.nextInt reads an integer from the keyboard. We store that in some input. And if some input is equal to 1, we create an undergraduate student object and add it to the student's bag. Otherwise, we create a graduate student and add it to the student's bag. So at compilation time, all that Java can do is ensure that there is a class called scanner, there is a class called system, it has an object called in, that this assignment is correct, there is a semicolon, etc., etc. Some input has a proper type. The type on the right-hand side matches some input. Scanner has a method nextInt. This if statement is valid, etc., etc. Again, also that add is a method in students. It takes this object as a parameter and so on. What it cannot do as it is compiling is execute it and see what happens. There is no way that for it to know whether line 22 or line 24 will get executed. Which one of 22 or 24 will get executed? That depends on some input. That depends on execution. So I have to run it. So I have to press this button before I can type in a value. So this is not going to be known whether 22 or 24 will get executed until and unless I execute. So there is a distinction between compilation time and execution time. So at compilation time, there is no way to know whether an undergraduate student will be added or a graduate student will be added. So understand the distinction between these two states. Now, let's see what dynamic binding is. Let's see what this code is doing. I'm creating a bag. There is, you have seen the code for this bag before, so I'm not going to explain this. This was, I adapted an int array bag to be able to store students. So I'm not going to explain much. You can take a look at the code. You can take a look at the video for bags if you're not sure. So here is the student array bag being created in a driver program. And I add 5 undergraduate students. I generate the names like this: UG student 1, 2, 3, 4, 5, add them to the students bag. Then I create 5 graduate students and add them to the students bag. Then I add a undergraduate student and a graduate student. And so I have 5 students added here, 5 students added in the next loop, 2 more students here. So I have 12 students in my bag. I didn't remove anything, so I should be having 12 here, 12 students here in the bag. So I have a loop that iterates 12 times, and look at this line. Line 29. What am I doing? Students.get data at index dot add course and a couple of parameters. Let's dissect this. Students is of course the bag. Get data at, you should know what that is. It is something we have discussed before. Get data at of a bag given a position. It returns the object at that particular index. And it is a student. That is the declared type of this method. This method get data at is declared to return a student. The actual type depends on the execution. So students.get data at index returns a student object, and I'm invoking a method called add course, which we have not discussed. What is add course? Add course is declared in student. And how does it work? Protected void add course int credits double grade. So the situation is some student or this student has taken a course, has completed a course with these many credits and this grade. So maybe 4 credits and the grade is 3.0. What we are doing is increase the number of credits the student has taken here. Number of credits is number of credits plus credits. That is one statement. The other statement is we recompute the GPA. So GPA times number of credits before the course was taken plus the grade times credits. If you add them up and divide by the new number of credits, you will get the new GPA. So we recompute the GPA. So this is done for all students. Okay, so it is in the student class. But there is a subclass of it. Let's look at graduate student. Graduate student has the same method add course, but it is an override. So it has the same parameters, credits and grade. What am I doing here? I am calling super.add course. So I am getting the course added to the student's record. So the number of credits is increased by this method add course in the superclass. The grade will be adjusted. Now I check if the GPA is less than 3.0, we have a graduate student, so they need to have at least a 3.0. Status is on probation. Otherwise, status is in good standing. These are static fields on probation and in good standing in the superclass. You can see them here. In standing and on probation. So those are done here. Similar to this add course in graduate student, there is a add course method in undergraduate student too. It works very similar, except if the GPA is less than 2.0, we say that the status is on probation, otherwise status is in good standing. So let's see the test students code here. Let's reflect on this a little bit. Let's imagine the compiler compiling this. what is it checking? It knows that students is a bag, and there is a method called get data at with an int parameter. So it knows that this returns a student object. It doesn't know what the actual type is. It knows that it is going to be a student object. It is of type, the declare type is student. And it sees that add course method is invoked. So what it does is it checks whether there is a add course method in the student class. That is important to understand. The compiler is checking that add course is a method invoked on a student object. So it has to ensure that there is such a method in the student class. That's all it can check. Of course, it can also check that the number of parameters and their types are all correct. It will check all that. So it verifies that it is getting 2 integer parameters, or rather, whatever the integer maybe this might be checked for double. That doesn't matter. It ensures that the parameters are also correct. But what happens at execution time? At execution time, this will return sometimes undergraduate students, sometimes graduate students objects. So this method called add course is going to be invoked sometimes on undergraduate students and sometimes on graduate students. That is the important thing. That is the big thing about dynamic binding. At execution time, the actual type of the object here, not the declared type, the actual type is used to decide which method will be called. Add course will be called on a graduate student if students.getData is a graduate student object. Otherwise, it will be called on the undergraduate student object. That is, if the actual type of this object is, this reference is undergraduate student. So the actual type of the object is used while invoking methods. This is called dynamic binding. Why are we saying it is dynamic binding? When Java is compiling this piece of code, it doesn't know whether this method in graduate student or whether this method in undergraduate student is going to get called. It doesn't know. All it knows is that it is going to call add course of one of those 2 classes, or it could be from student. So the determination of which method gets called is dynamically determined at execution time, not at compilation time. So it is a determination made at execution time. So it is called dynamic binding. Similarly here, we add more courses, and this will, again, the stuff is identical. So the code is identical. So you can, so everything that we said about this line 29 applies to 32 as well. Similarly here, we are printing out all the students. So you can execute this program and see how it runs. Students.getData at index will return sometimes an undergraduate student and at other times graduate student objects. So the parameter to the print line method would be sometimes undergraduate students and at other times graduate student objects. So this will invoke the toString method of undergraduate students sometimes when the actual type is undergraduate student, and toString of graduate student when the actual type is graduate students. Again, the determination is made at execution time. So this is again dynamic binding.